So let me briefly introduce myself and Erez. All right, so I'm Sagi Smolarski, lead coach and partner at AgileSparks. I've been with the AgileSparks for about 11 years, quite a long time, enjoying most of it, all of it. And lately, I find myself more and more answering questions and queries about predictability from clients I'm working with. So I'm drawing from my personal experience about best practices, also some experiences about best practices from coaches in AgileSparks, and also from science. So it's based on some scientific research and facts. So that's me. Erez, do you want to introduce yourself?
Yeah, hi, I'm Erez. I'm actually going to be helping Sagi. So Sagi is going to be the main speaker. I'm founder of AgileSparks. I like to describe myself as a lifelong learner. I like to learn a lot, and the subject of predictability is very close to my heart because in many cases, we see organizations that are interested in the question, when is it going to be done? And of course, this is a very important question, and we will try to see how this can be answered while not losing our ability to be agile. So,
all right,
go ahead.
And so we're part of the AgileSparks team. That's pretty much the complete team, or close to that. And just a few words about AgileSparks, Erez.
Yeah, so we were founded 15 years ago. Basically, what we do is we help organizations become more effective and efficient, happier too. We do that by helping them transform to agile/lean ways of working. We have global presence, so we are speaking here. Both Sagi and I are based in Israel, but we have an office in the States. We also have an office in India. We work a lot with international companies. We are recognized by organizations such as the Scaled Agile. We're a gold partner. We're also a representative of Scrum.org, Atlassian solution partner. We provide classes on an ongoing basis. I urge you to go and look at our feedbacks and look at our schedules. And mostly, we're very proud of our case studies. So this is also available on our website. We don't work with organizations just to say that they're agile. We're working with them to become more predictable, have higher quality, better speed, and so on. So we have proven results from over 450 organizations that we work with throughout the years. Sagi?
All right, thank you, Erez. So about predictability, we are all aware of some colossal failures of predictability. One that is recent, I just got that from news outlets in Israel about the Tel Aviv light rail and how much behind it is and what's the staggering cost, and it's really a catastrophe. But oftentimes, that comes closer to home, and we can see those failures in our projects, in the companies we work for. So it's definitely painful. So we'll talk about making the case, first of all, for predictability, because seemingly agile and predictability are sort of an oxymoron. So we'll try to understand, when this is justified. We'll talk about what exactly do we want to predict. I think it's important to be clear about that. We'll talk about why it is so hard. We'll talk about lean and predictability, how we can actually leverage lean and agile to be more predictable. We'll talk about estimation, which is actually key, or at least understanding estimation and the pitfalls of estimation are key to being more predictable. We'll talk about some principles of forecasting. And last but not least, we'll talk about some algorithms, some validated and well-known algorithms for actually improving predictability. So let's get started. It's going to be quite fast-paced. So I hope we have some time for questions at the end.
Yeah, I just wanted to mention before we dive in, Sagi, if anybody has a question, feel free to use the Q&A button at the bottom. I'm going to be monitoring, and if there is anything that is of interest, I will notify Sagi. So please use the Q&A session at the bottom.
Sounds good. Thank you very much, Erez. So I just sent a link here, and please, if you can come in and leave that window open, because there are going to be a few questions there. So you can just get in. It's a Mentimeter link. And the question for you is, what's your prediction horizon? Meaning, how far forward do you need to predict and to commit? So we can see the answers live here. All right, so I can see that there's a strong majority for sort of quarterly predictability, which is very typical, especially with the advent of safe. PIs are typically 1 quarter or close to a quarter, so it's not surprising. But for some of you, it's definitely much more than that, more than a year, which is definitely a struggle. But that happens as well. All right, so thank you very much. So we can see that for most of you, it's 1 quarter or above. Excellent. So thank you very much for your input. That's very interesting. So seemingly, there's the Agile Manifesto. Like I said before, there's a tension between predictability and being agile. Because if you look at the Agile Manifesto, which sort of pretty much defines what Agile is all about, you can see that one of the values, which are defined as this over that, calls for responding to change over following a plan. So predictability is all about creating a plan and being able to actually predict when this is going to be done. And so seemingly that contradicts Agile, right? I mean, the world of Agile is one in which you start by having a vision and then you work in baby steps. You get feedback all the time from users, customers, and then based on insights that you learn from that feedback, then you may decide to reprioritize, redefine, refocus, or even completely change direction, so pivot, right? So per Agile, that's the best way to work. But there's still in many organizations, pretty much all the organizations I'm working with, there's definitely a good case for predictability, right? So this is a great approach, but in many cases, you cannot actually fully apply this approach, right? So sometimes you have some real firm deadlines that are dictated by the market, by compliance to some regulation or some larger organization. You have some contracts, right? So what can we do? These are part, fortunately or unfortunately, part of our reality. So it's part of making a case. You do want to manage client expectations oftentimes. Clients, before they commit to buying your product, to staying with your product, they need to know when they're going to get what. They are actually asking for that and pressing for that. And also being predictable helps build trust with the stakeholders, which is very important. Also, there's a situation oftentimes where there's a tight prioritization due to competitive challenges. For example, getting to parity with competition, so having the same features as the competitor, and also budgeting of large initiatives, especially initiatives that have to do with transformation, modernization. You need to know how much it's going to cost because you need to prioritize that. So if it's too costly, maybe you're going to decide it's not worthwhile. You're not going to get into the project from the get-go. So there are some very good reasons for being predictable, even when you're trying to be as agile as possible. So these are all valid questions, but still, I think that even when these exist, you should still make an effort to get feedback early and often. So try to carve out, an MVP or an MVF, a minimal viable feature, and do leave some space for the unknown and unexpected. So it's actually, it's sort of a balance. So it's usually not 100% predictive or 100% responsive. But if you're committing all of your capacity to 100% long-term predictability, you are definitely limiting your ability to respond to change. So my recommendation is try not to do that. So we'll move to the next question. And so if you can get back to the Mentimeter window, I'm interested to hear from you. In terms of the balance, is it in your company, do you have the expectation to be fully predictable, as in 100% of the effort is invested in 100% predictable endeavors, or is it more like more to the left, where it's a much more sort of responsive, adaptive? So it's interesting to hear from you. If you're strongly agreeing to that statement, that means that you need to be 100% predictable.
I think it makes sense to resend the link to the Mentimeter if anybody closed it. Okay. It'd be easier to get to the page. So look at your QA button at the bottom. Yeah. Sorry, look at the chat.
It's in the chat. In the chat, you can
leave it. You can leave it open throughout, but if you missed it for some reason, you can repress it and answer the next question.
And by the way, in that slide on the top, there's also some information about how to join. Just type in, menti.com. There's a poll ID. That's also a possibility. Okay. So I see that for you, it leans more toward, being very predictable. Like that's 3.4 out of 5. All right. So predictability is pretty important. And that's definitely very typical of the organization I've been working with. So the next question is predicting what? Because it's very important, to set, our terminology right. And there are a few options there that I've seen that I used. One of them is predicting throughput, meaning how much output can we generate. So for example, by the end of the quarter, we'll get 135 done, whatever the unit is. So, there's a need to predict how much we can actually create in terms of, volume, effort, estimate, something like that. That's throughput predictability. A second option, which is quite common as well, is which work items will we complete. So that's typically features, as in like login using Facebook account. That's a feature, and we want to know, is that going to be included in the next release or not, or in the next PI, right? So that's output predictability. And the third option is outcome predictability, which is what impact are we going to create. So typically that's defined using OKRs or PI objectives if you're using SAFe and PIs. And so an example can be, well, we want to have 30% increase in registration. Maybe the logging in using the Facebook account is going to help us achieve this, but we're actually shooting for a particular outcome. So I think that the one on the right, the more to the right you are, I think the better it is. It's just that there's a danger. If you're shooting only for throughput and output, you are in danger of being sort of a feature factory, where it's all about getting work done, which is probably not the best endeavor. So definitely one tip is to prefer predictability of outcome. So define your predictability in such a way because it's more meaningful, right? There's going to be more motivation, more engagement from your people. It's more inspiring. And gives you more flexibility, right? If you know what outcome you want to get at, you can actually change, which features, which user stories, you can change the way to get there. So you definitely build in some flexibility. So back to Mentimeter, I'd love to hear from you. What do you predict mostly? Is it mostly throughput, output, or outcome in your organization? All right, so first of all, I have to say I'm pleasantly surprised that there's a non-negligible portion of the people that are attending here that are focusing on predicting outcome, which I think is awesome. I think that's the best way to go. So that's great. But definitely the majority are more toward the output and some on predicting throughput. All right, thank you very much. So sorry, back to the presentation. So also another thing that I want to consider about predicting what exactly, there are definitely two different types of predictabilities, and one of them is single item predictability. So what you're asking there is when this will specific item be done. Typically it's going to be a feature, and you want to know when this is going to be done. You may predict different items at any point of time, but you want to know each item in specifically when it's going to be done. The alternative, which is also very common, is when you have a release or a version, which is sort of a batch of features, of capabilities, then you want to know when all of these are going to be done, when is the release or the version is going to be ready. So this is referred to as the batch predictability. The reason I'm mentioning that is that there are different tools, methods, and best practices to actually predicting those two. So I'd love to hear from you, getting back to Mentimeter. That's going to be our last question is what do you need to predict typically? Is it going to be both single item, batch? All right. So we have a mix there. Mostly both. All right, that's an interesting mix. Okay, but typically it's going to be both. So for most of you, you need both single item and batch. All right, so I'll definitely talk about both of them. Okay, so let's move to the next topic, which is why is predictability so hard? There are some good reasons. One thing that I would like to expose you to is an experiment that I actually conducted at a company I'm working with. And we took a few people, a group of about 70, 75 people. All are, project managers, team leads, software developers, and so on. So pretty much from our own world. And what they were asked is to actually estimate this. You can read it really quickly. Please estimate the following task. Create a spreadsheet which calculates the total price of a single item, including sales tax, given the item's price and US state. For example, given an item costing $1 at the state of Kentucky, which has a sales tax of 6%, I actually looked it up, the display price would be $1.06, right? So what would be your estimate in minutes? So think about that just for a moment. How many minutes do you think that would take you to actually implement something like that? And I won't be collecting your estimate, but I did that, and so I'm going to fast forward that, but I'll show you the results. I actually collected the results in something like Mentimeter, and the result is something like that. You can see that's the median, the big purple circle, and the individual points are individual estimates. And one thing that you can see there is that first of all, the median was 15 minutes. That was the median estimate. But what's even more interesting is that the range was actually huge, between 1 and 600 minutes. For the same, which is the same task, which is actually quite simple. If you are looking at sort of the spectrum of complexity that we typically have in the projects that we are running, then that's probably on the lower end of the spectrum, right? That's a very straightforward thing to estimate and to actually carry out. So you can see that the range is huge. And what the participants didn't know actually is that they were displayed. There were two different versions of that question. You can see that there's version A and version B. There are some slight differences. It's the very same thing that I'm asking for an estimate. It's just worded and displayed in a slightly different manner. I'll actually point out later what are the differences. So there was version A, remember version A, and version B that was a bit more complex in terms of how it was explained and displayed. And you can see here the difference between version A and version B. So again, same task, and you can see that there are some significant differences, right? Significant differences between the median estimate in one and the median estimate and the other. For the more complex display, again, it's the very same, description. You can see that it was 16 times, had a 16 times higher estimate. So 4 hours versus 15 minutes, right? So 16 times, which is a huge difference, right? So, and you can see here, I'm pointing out the two versions side by side, and the differences. You can see that in one, the price was higher, which is obviously totally unrelated to the task itself, right? And you can see that the estimate was requested here in hours versus in minutes. And you can see that it was a bit more verbose on the version B. You can see also that the font was different. You can see some slight differences that are unrelated to the task itself. You can see that they have really a huge, a huge impact on the estimate, right? So average estimate is again 16 times higher. So there are many cognitive biases that affect our estimates, and many of them have been documented. There's actually a long list. These are just some examples that I actually used here in this particular experiment. Same requirements, more words, you get a large estimate. Same requirements, a cursive font versus a non-serif font, you get a large estimate. Same requirement, but a hint of size, like in our example, that was just the price that was different, which is totally unrelated. Different estimates. This is called referred to as anchoring. So I used those three, and you can see the differences are huge, right? We're not talking about some trivial differences, right? So the insight here is that individual estimates are little help in forecasting, right? You cannot rely on estimates. That doesn't mean that you should give up on predictability, but definitely you need to take estimates with a very large grain of salt, right? So we look at one thing that you can do to actually improve the estimates. It's called reference class forecasting. That comes from this guy. This is Daniel Kahneman. We'll talk about that. We'll revisit some of his insights later on. So per Daniel Kahneman, to actually create better forecasts and better estimates, you need to use something called reference class forecasting. It's built on the following insight, right? If I'm looking at that landscape of offices, and so there are different offices building, and I'm asking you, try to estimate how much office space there is in this specific building in square meters, right, or square feet. And so you can try, you can estimate it. You'll probably get it wrong, which is fine. But the question is, how wrong will you be? And probably quite wrong. I can also ask you about that building, which is larger, right? How much office space? But if I ask you how many more times there is in the left-hand office building relative to the right-hand side, then it's going to be much easier actually for you to estimate that. And this is what reference class forecasting and estimating actually is trying to leverage. So we are better at relative estimates. So relative estimation works better. And what does that translate in terms of real life practice is that you can use a reference table. You already implemented some features, right? So you acquire some history, and you can put those into sort of bins, right? You can use t-shirt size, which are very common. Typically, I would recommend that you translate the t-shirt sizes into an actual real size number, because you'll use that later. You do need that. But then we know when there's a new feature that comes in, you can actually ask yourself, is it closer to a new report and adding an auth provider, or is it closer to a new filter rule and modifying a query? So based on that comparison, you can have actually a pretty good idea of how big it's going to be. And then you can use that knowledge in planning, right? Let's say that you are planning your first PI. And so you have a mix, you have a backlog of different sized features. You have 3 large features and 1 medium feature and 1 extra large and so on. So we looked at the numbers before. There was a number assigned to each one of those t-shirt sizes. So the whole plan amounts to, in this particular example, 250, right? So that's the size. That's the effort estimate, right? So then that PI ends, and you see that, well, we finished, those blue ones were completed as in done, ready for release. And that large one, the extra large one of them was not even started, one of them was not complete, so we don't count them. And actually, you had a couple of features that came in and sort of bypassed, the features, so sort of emergency, or we forgot about those, sort of features, 1 small and 1 large. So you got these completed, that's very common, that you start with one plan. It actually changes to some extent. So you finish those, and if you sum it all, you see that you finished 180 out of those 250, and 130 out of the original plan, because those sort of yellow, whatever that color is, are not counted, here out of the plan. They were not part of the initial plan, and that's a big help in helping you plan the next PI, right? In next release of PI, you can commit to 180 if you are trying to forecast the throughput, and you can commit to 130 if you are trying to forecast the output. Because I can pretty much guarantee you that next PI, there are also going to be a couple of features, or roughly, that are going to creep in, right? So in that case, your PI velocity is 180, right? And velocity, a definition, just to be clear on what the definition is, velocity in general is how much effort estimate we completed in a fixed duration. And the fixed duration, and by the way, it's historical by definition. There's no such a thing as forward velocity. It's always going to be based on the history, what we completed already. And that can be, story points per sprint. That's going to be sprint velocity. That can be story count per sprint, which is also valid. That can also be story points per release or PI, the PI velocity, which matches the example we just saw. So that's your velocity, and you can use that. So first tip is use reference class estimation, estimate by comparing to previous items. And the second one is use yesterday's weather to forecast, develop a release/PI velocity. Based on that, it's much, much easier and feasible actually to plan forward and to forecast, okay? So these are 2 tips. Just to give you more sort of ammunition to, or give me more ammunition to convince you that estimates are not worth a lot, we can look here at a chart that shows on the x-axis, the horizontal axis. These are effort estimates for features. We're talking about features here. How many days of effort people estimated they need to actually implement that feature. And on the y-axis, the vertical axis, it's the cycle time, meaning how long it took in days from start to finish, from the moment you started working on the feature until the moment it was done, ready for production. So what do you think the points are going to look on that chart? right? So if you're an accountant, the accountant's assumption is going to be that they're roughly going to fall on a line, right? There's a relationship, a linear relationship between the two, and more realistic, what I would assume is that there is a relationship. It's probably not linear, more like that, because from what I know, the larger the feature are, the more complicated and complex they are. The harder, the more uncertainty there is. So it's going to be like that. But actually, what you get is something like that, right? So you can see here there's a large number of features, about 130. And you can see that there's almost no relationship. The correlation is very low. 0.08 means essentially that there's almost no correlation. And that's one example, one specific project, a large project. But I've checked actually quite a few projects, and to my surprise, that this is actually quite common. That's very typical actually. So typically there's no correlation, right? So that's surprising. And what that means is that, again, the relationship between the size and the cycle time is very weak. And so at the very least, you need to communicate duration and effort estimates separately and be very clear about that, right? Duration is when will it be done for a particular item. And estimate is something else. Is it worthwhile? Should it be sliced, right? That answers in different set of questions. Right, one thing that you can use, actually, the closest thing you can use to actually predict how long it's going to take to get a specific feature done is you can just, chart on that's a violin chart or the distribution essentially of the cycle times, the cycle days in that case. That's, by the way, the same data set we saw before. And one thing you can say here, there's a bracket, 80% of the points fall within a specific range. So you can say that there's an 80% chance that the feature will be done between 44 days and 190 days. Now, that's a very powerful statement because, first of all, it's true, based on historical data, and it's realistic. It does not require any estimation, and it's not item specific, right? And you can affect it. The good news is that you can actually, narrow it down. That's one thing that you can do. And for single item predictability, so you have to use, unfortunately, cycle time to forecast. Estimates are not a big help. So, and less variance in cycle time means better predictability. We'll get back to this one in a second. So I'd like to present a case study from a company called Click Software, an Israeli company, which is now a part of Salesforce. And the credits go to Oded Tamir from our team, from AgileSparks, from bringing that. And so they had an Agile release train, so using SAFe, 120 people, and they improved predictability significantly from 60% at the PI level, at the quarter PI level, from 60% to 95%, which is quite remarkable. So they used not outcome predictability, they used actually a mix of throughput and output, but still, it's still definitely a nice thing to get, right? To get an improvement in predictability of that magnitude. And let's look at what they did to actually achieve that. So the first thing they did is that they removed the bottlenecks. Their specific bottlenecks were about DevOps, so they pulled DevOps into the team, so created DevOps capability into the team. Another bottleneck was testing, in particular stress testing. So they automated that and moved their test responsibility to teams. So that's one thing that they did. The second thing was to fix the team structure, and that's something I'd like to delve into briefly, just for us to understand that, to understand what does that have to do with predictability. So let's look at a typical family car. That's a Tesla 3. And if you take a teenager that has never driven a car before, and you want to teach him how to drive such a car, right? Get his driver's license, essentially. Roughly, it's going to take you around 30 hours, maybe 20, maybe 40, maybe 50, but that's roughly the ballpark number. So that's a 2D problem, right? A car is something that drives on the face of the earth, right? Like roads, right? So that's 2-dimensional. If you look at a similar problem, but in 3 dimensions, right? That's a plane. That's a typical modern family-sized airplane, right? That you can buy. It costs about $1 million. A bit more expensive, much more expensive than the Tesla. And you can see that controlling that, just by looking at the cockpit, you can understand that controlling that and learning how to control that, is much more complicated. It takes a much more time. At the very least, it will take you from 0 to being able to fly this safely 300 hours, so that's 10 times more. Okay, so adding a dimension multiplies complexity. So it doesn't, add to complexity; it multiplies complexity. Just to clarify this analogy, in our world, the world of project management, typically you have the time, which is in one axis. The second axis is the outcome of or capabilities, what we are trying to predict, and the x-axis is the time. So that's a 2D problem to try to predict and control that. Versus a 3D problem where you add another axis, which is staffing. So moving people mid-project from one project to another, from one team to another, and changing, the assignment and the capacity. So working on multiple releases and balancing the amount of work on each release. So that makes it much harder. That adds a dimension, and so that makes it 10 times harder to understand and control and to predict. And that's why you want to actually use fixed team structure as much as you can, right? To vary it very slowly. Otherwise, it's going to be much harder to be predictable. Okay. So, and just to give you some more insights about about the basic sort of physics laws of software development in terms of accounting, this guy's name is Fred Brooks. He was one of the first people who managed a large-scale software project that was the operating system for the IBM 360 series of mainframe computers back in the late 60s, so a long time ago. And he actually wrote a book about his experience managing that. The book is called The Mythical Man Month. I really hope that you guys had the opportunity to read it. I definitely recommend reading that book. It's an awesome book even today. And one of his insights is referred to that he mentioned in the book is referred to today as Brooks' Law. And what it states is that adding manpower to a late project makes it later, right? So that flies in the face of standard financial accounting principles, right? So if I would ask a CPA, like an accountant, to predict, then he would say, well, project is late. Let's add more people. Let's that will move the date earlier. It doesn't work like that, right? So one of the insights there is that you cannot use standard accounting principles for software development, and that's another reason why you want to avoid, using varying the staffing, right? So avoid varying capacity and team structure. It's much easier to drive a car than fly a plane. And improve flow. That was the first insight from this case study. So track and reduce cycle time and identify and elevate bottlenecks. So by the way, if you track and reduce cycle time, will be much more predictable in terms of predictability, both of single item, and in terms of batches. And also you will improve your efficiency as an operation. So it's definitely worthwhile investing into creating flow and reducing cycle time. By the second insight comes from this guy, that's Eliyahu Goldratt, the guy who actually created the theory of constraints. And so that's definitely recommended that if you want to improve predictability, try to be leaner. These are part today of the sort of the lean body of practice. So that's another tip. Back to Daniel Kahneman. Daniel Kahneman, by the way, if you don't know him, is a psychologist and a behavioral economics pioneer. There's no such a thing as the Nobel Prize in psychology, but there is a Nobel Prize in economics, and he actually got that prize in 2002 on his insights, on his research on behavioral economics. He pretty much founded the field, as far as I know. And one of his main insights is that something he refers to as planning fallacy. And what it says, what it means in his own words, is that's a phenomenon in which predictions about how much time will be needed to complete a future task or project display an optimism bias and underestimate the time needed, right? And if you look at some data from the field, from our own industry, right? This chart actually is taken from an article. You have the link here, and once you get the presentation, you'll be able to check it out yourself. That's based on a couple of separate, unrelated databases of the software projects. And what they did essentially is that they asked those projects what was the initial estimate and what was the actual result, right? So if projects were completely predictable, all those points would actually lie on that line. That line is the line where the initial estimate and the actual results are the same. As you can see, they are pretty much all above that line, which sort of reinforces the insight from Daniel Kahneman. Now, if we take those two numbers, we take a point here and we divide one by the other. So actual results divided by initial estimates, we can create sort of a distribution of those numbers. And you can see it here. So that's actual divided by estimate. And you can see that on average, the projects are takes twice as much time to complete as was predicted, right? So that's based on two different projects database. You can see that they are very close to one another in terms of predicting that. So one insight is that projects on average take twice the time, especially if you don't use modern tools to predict and update your predictions about them. And the second insight here is that forecast should really be a range. I mean, if you want to really forecast a project, it's not enough to say, well, I think it's going to take, our estimate is going to take 1 year, so I think it's going to take 2 years. You probably want to provide a forecasting range, right? So the second insight is that, the one insight is that, again, it's as much as you plan, you will likely get it wrong. So forecasts are a range rather than a single number. Okay. So how do projects get so late? And the answer is just 1 day at a time, which means that you very much like Waze does it. It updates sort of your estimated arrival time based on changing road conditions. As you get closer, it has more certainty, even though it doesn't show you what's how certain it is about the arrival time. But forecasts need to change as we go, as we progress. That's very important in terms of managing, predictability and communicating, setting the right expectations. So as much as you plan, you will likely get it wrong again. And another insight is that you should continuously update your forecasts as you progress. So we'll talk now. Our last topic really is about forecasting and tracking, how to do that in the right way, right? So the typical way that I've seen in organizations, and you guys can tell me if you think in the Q&A if you've seen something else. But there are project managers that have they have an Excel, and they take the total capacity. So for example, the number of development days available, and they multiply that by some sort of load factor. And there's always a lot of many heated arguments about whether it's going to be 85% or 90% or 70% or whatever that is. And then they take the content, the total estimated time needed to complete, or estimated effort, the estimate. And then if those two match, then we're on track, right? So that's pretty much the way it goes. So just as an example, let's say that we have one sprint, we have 5 developers, and that's their availability in days in sprint 23. So we sum up all the capacity, that's 23.1 days. And we multiply that by 85%. So we end up having an effective capacity of 18.48, very accurate, right? And then next sprint, the effective capacity is actually going up. So 24.67. Next sprint, that's Passover, that's a holiday. So most of the people are out, so it's going to go down. And so on and so forth. So the total is in those 4 sprints, I summed it up, 75.13. And the total content is 70. So we're roughly okay, right? We even have sort of a small buffers, and we like buffers, so we should be okay. The thing is that that doesn't work. That never works out that way, right? Again, we started before using financial accounting for complex human endeavor is wrong. 1 + 1 = 2. Doesn't work like that. So the very assumption formulas that you are using in that model are wrong from the get-go. And this is built on future hope estimates. Like we saw before, estimates are wrong, pretty much always, by definition, very wrong. So it's based on future hope rather than past evidence. It invites many of the psychological biases that we saw before, like optimism bias and confirmation bias and so on and so forth. And it also invites, wrong assumptions and miscalculations. Almost always, for example, in those spreadsheets, something that is not accounted for is scope creep, right? So, and it hides many of those assumptions in Excel formulas. So I think, that's very dangerous to use that method to actually forecast or create an up-to-date forecast. So the tip here is that, don't rely solely on using forward-looking custom models. These typically don't work very well. It's okay to look at that, to use it as a reference, to do what-if analysis, but take that with a very large grain of salt, right? So, one thing that is needed, if you've ever seen, the financial reports of a corporation that is listed on the stock exchange, on any of the stock exchanges in the US, Typically, they report that on something called Form 10K. And there's actually a standard, it's called the GAP, the Generally Accepted Accounting Principles, which actually defines how they are actually reporting their financials, both in terms of current financials and forward-looking financials. And that way, you can actually do some forecasting, some financial forecasting. So it's built on a set of best practices. And I think that we need something like that in software development as well. And we can do that using algorithms. There are actually a couple of algorithms I'll talk about that are actually exactly that, at least if you do them the right way. First one is linear extrapolation, which is a very simple algorithm that we typically learn in a math class in high school. And it goes like that. You look at an ALM tool, right, and as an Agile lifecycle management tool, which is typically Jira or Azure DevOps or whatever you're using. And you have the scope at the beginning of the PI or the release or the project, right? So you look at the scope and there's a target date that you got to somehow. And now you're trying to know if you're on track, right? So as the time progresses, you can see that you're starting to complete some work. Typically, these are going to be user stories or features, depending on what you decide to track. So you see that this progresses, and the scope never stays the same. It always increases. That's referred to as scope creep. I've never seen a project for which the scope does not increase, because as you progress and you look closer at the stories, you understand that you are missing some stories. You understand that the stories are bigger than what you thought. That's okay. That's okay. And if you want to know if you're on track, then you can just sort of do a linear extrapolation of those points, or a linear regression, and you can see where those two lines are meeting, and that's the predicted date. That's your forecast. Typically, or maybe I should say always, from what I've seen, this is going to be later than what you would like it to be, but that's okay. At least you have a more realistic and unbiased sort of a view of when things are going to be complete. An alternative to that, which is is completely equivalent, is to sort of merge those two curves together. So essentially take the remaining, which is essentially the scope minus the completed, and then this remaining should actually track to 0. That gives you the forecast. Exactly the same thing. So that's less biased than custom models from my experience. There's no need to track actuals and capacity, so it's very easy to actually chart that. But there are some caveats with linear regression forecasts, and so one of them is referred to in the scientific literature as coordination neglect, or the long tail. Typically, it goes like that. You start tracking, and here you are progressing. It seems like sort of converging. Yeah, we're sort of on track. We're sort of on track. And at the end, the last 20% of the work takes 80% of the time, or something like that. So maybe not to that extent, but it's typical to see a curve like that, right? And the reason is that the stuff that is done, but not done, right? It hasn't been really, tested in the right environment. It's not production ready. It hasn't been integrated, and so that's really infuriating, right? If you're doing that, then if you're not, completing stuff to the point where it's done, then that's a problem, right? So you want to avoid the long tail. Use an expensive definition of done. Things like, a feature is not counted as done if it's not secure, fully integrated, fully tested, demoed, cleaned up, right? So refactored, you added the automated testing. So it's very important. Otherwise, that prediction, that linear extrapolation is not going to work for you, right? By the way, Jira has that, like that sort of forecasting, that linear extrapolation. You can see here an example. The thing is that the tools Jira included, typically they don't take into account scope creep, so Jira does not, for example. Often they don't know how to aggregate at different levels between features and epics, and so that's a problem. And also, it's impossible to add your own forward-looking knowledge to affect the forecast. So there are quite a few shortcomings, to the point where I've seen many organizations are not using them, and I can definitely understand why. But an ADO has also some limitations. That's Azure DevOps. Still, it's quite simple to create, right? There are add-ons like Easy BI or Power BI, or maybe outside of the tool, you can actually export the data from the tool using its API and use any kind of outside tool. I have an example here. This particular one is for a real project, and you can see that this one was actually created by exporting data from the Azure DevOps via its API, and I'm using pandas and plotly Python tools essentially for the analysis. And you can see that the forecast completion here was August 7, and as you can see, it's way beyond the forecast date. And the project manager said, well, our spreadsheets show that we're on track, right? No way, it doesn't make sense, right? So we had to actually drill down into the data and prove to ourselves that we are looking at the right thing. And that's, fast forward quite a few sprints. You can see they actually created some extra sprints. You can see that actually it ended up being quite accurate, right? As much as they tried to stop the scope creep and to increase the velocity, which, seldom works. Again, think back about, Brooks law. So that ended up being much more accurate than their own, model. Okay, so that's an example. Some tips about linear regression. First of all, again, avoid the long tail. Use an inclusive definition of done. So look at accepted, for example, rather than dev complete, and slice things vertically. Not, we finished everything, but the integration, wasn't complete. For example, the UI wasn't complete. Add the ability to track across work item levels between scope and completed. Track scope creep as well. This is very important because that's oftentimes omitted. Don't update an item's estimate once you start working on it, because otherwise that thing becomes sort of a timesheet, right? You want to know how much of the estimate you actually completed. No, not how much time you actually invested in the project. That's a different question, right? And use a single tool across projects, which is consistent and validated. So there's a saying that I like, which is with enough eyes, all bugs are shallow. I mean, if every project uses its own sort of spreadsheet with its own assumptions, then it's more likely to be wrong. Sets of forecasting guidelines. If you have a PMO, so there should be a clear set of guidelines. And you can definitely use the history from previous releases to forecast early. You don't need to wait a few weeks past the PI start. The last method I'd like to cover is the Monte Carlo method. It's called Monte Carlo after the casinos in Monte Carlo because it's probabilistic, like games in a casino. And it was actually invented in the Manhattan Project. The project that actually created the first atomic bomb. They used that to actually simulate some explosions, and they had very weak. One of the first computers, it was not strong enough, so they had to resort to some creative methods. And it's all about using random numbers to simulate many probable outcomes, in our case of a project. So let's look at an example. So let's say you have that project. Again, you have the remaining effort. These are data points, each one separated, say, by a sprint in that case. And we want to know, well, when is that project going to be complete, right? So the question we ask is, what's the next point, right? Next point can be anywhere. I mean, we don't really know. We can estimate. We don't really know, right? So what we do is that we can look at the history, right? So the history of the deltas in the remaining between from sprint to sprint or week to week, whatever you choose, then it can be 5 or 4 or 0. What we do is that we just roll a dice, and we roll that dice that picked, the second number here. And so that's the number we pick. That's going to be the delta, right? And that counts as one roll of the dice. And we do that again. We roll the dice again, and here there was a sharper drop, and again, and again, and again, and again, and we do that again until the project ends, right? And here, this project was complete after 15 rolls of the dice. That means that 15 periods or 15 sprints in that case. That's what we needed in this particular example to actually complete the project. So we do that once, simulate a full project, and we just did, and we do it again. So we'll have a different result because it's probabilistic. And again, and again, and again, and we do that maybe 1,000 times or 10,000 times. And then what we get is sort of a histogram, a distribution of outcomes. And that distribution is great because that's going to give us a range, right? So we can put that on our chart, and we can see, what are the probabilities of the project completing at a particular time. There's sort of a mean, right? An expected value, that's the most likely. And there's also a range, 90% chance that it's going to finish, in one particular, in a particular range. I can show you a quick demo of such a tool. This is a web-based tool, so you can load historical data or just use, there's some sample data here. You can simulate it, and you see it's quite fast. You get a computer can do many simulations in just, a couple of seconds. So that I think that's 10,000 experiments, and you can see the distribution here. So you can see there's a 90% probability that this project, based on the remaining and the dates, is going to actually complete between February 9 and August 17, 2025. And the forecast date, so that's going to be the expected, is going to be May 11, 2025. And that's a linear extrapolation. And here you can see the combined results. right? So here you can see that the Monte Carlo is actually a bit more optimistic than the regression, but it really depends. Sometimes it's going to be the other way around. You can see that the range is actually quite wide here. If you have the more data points you have, so I loaded a data set which has, more data points, simulate that, you can see that as you progress, the range is going to become more narrow. So you're going to have more certainty about what is going to be the range, but it still is a range, and it should actually be communicated using a range. Okay, so that's Monte Carlo. So again, the forecast is a range, very much the same as weather. If you are trying to predict a hurricane, there's sort of a cone of uncertainty, right? You say, well, now it's here. In tomorrow, it's going to be between here and here. And here we have less certainty. It's going to be around, the circle is going to be wider. So the very same way you predict the weather, then you should also be predicting, the completion of a project. So there's a most likely completion date, a 90% completion probability of completion. So Monte Carlo, just a summary is that's a forecast with a range based on probabilistic outcomes of many experiments. It's actually great. That's actually, in my mind, the sort of the gold standard in terms of predicting a project completion. So that's pretty much it. I have a list of tips. I'm going to send you the links. Summary of all the tips I presented here. I'm going to send you the link in the chat so you can download it. It's a PDF. Essentially, this PDF. And if you want to read more, I can recommend a couple of resources that are more recent. One of them is called "When Will It Be Done" by Daniel Vacanti. And the second one is actually a podcast from Freakonomics, why your projects are always late and what you can do about that. So you can look them up. If you want to dig deeper, we also offer a forecasting seminar from ALM tool all the way to forecast. And obviously, we offer also some consulting and training on forecasting, and also some training in general, which we'll look at in a few minutes. But I'd love to hear your questions. So we have a few questions. Let's see. So first one from Yaniv Nakash: how to predict, estimate the effort for project changes. So like we saw here, there's the concept of scope creep, right? And that has a trend as well. So you can use the same method that we saw before. You can use sort of linear extrapolation or Monte Carlo to actually predict what's going to be the scope change with time. So the same method, actually, it's not if you should, but it has to be used as part of estimation and forecasting. So that's in answer to Yaniv. Taylor VJ: how do you take into account the overhead created by process data gathering and analysis? So the two methods that I actually presented here, so burn down using linear regression and Monte Carlo, there's very little overhead in terms of extracting the data, in terms of computing it. It's very low overhead relative to other methods. So there's virtually no overhead, I would say. Mark Koenig: I've never seen the Monte Carlo being used. Do I have what? I'm not sure what's the answer. What's the question actually? So that's something that you can implement. There's plenty of information about Monte Carlo methods on how to implement that. If you want more information, obviously feel free to reach out. And another question for Taylor VJ: how do you onboard stakeholders to the Monte Carlo prediction model? The stakeholders, so I need to explain then first of all what this model is. Using pretty much what I did here. So that's one way to explain what it is, why it makes sense, why it's better than other forecasting methods. And then you just have a tool. You get the data typically from your ALM tool, from Jira again, or ADO, and just you plug it into the model, and you can see that in a second you're going to get answers. From Sergey, we have a question: what is the right way to present predictability on a sprint level, monthly and quarterly? So on the sprint level, it's a bit different. We didn't touch upon that. First of all, because for the majority of you, the more challenging forecasting horizon is much beyond the single sprint. But I think many of the principles apply to sprint as well. And the best way to present that, I think, is using the Monte Carlo view like that, right? So something like that. There's the most likely completion date is this, and that's the 90% probability bracket. I think in my mind that's the best way to present predictability. From Amios: do you expect over time we'll have the same risk for linear and MC prediction? So no, they typically don't really agree. There are some discrepancies one way or another. From my experience, Monte Carlo is actually more accurate, and I love the fact that it has actually a range versus linear regression, which does not have a range. So it's not typically that you don't get the same outcome. And from Gil Vinoco, the last question: from your experience, which approaches work best to get companies to move from estimating to forecasting. So I think that typically, what I'm doing is that, I'm looking at the models that they're using. We are looking at alternative, better ways to forecast, right? Like Monte Carlo linear regression. And then we're actually tracking the project as it progresses. And we actually can see from, what I've seen in quite a few projects, then the forecasting was actually much easier to generate without any inside knowledge and without, any complicated tools, was easier to acquire and gave some better forecasts. So I think that people are, get convinced by seeing the results. So
there are actually some more questions that were posted on the chat, so we can go over them.
Okay, so let's really quickly, because it's important for me to wrap up on time and be predictable. So
yeah. So is there a tool that can be used for Monte Carlo? For sure, there is a tool. We have it.
So we have a tool that we are using. It's proprietary. So reach out if you want to hear about it. You can use also even, I've used in the past even, Excel or Google spreadsheet, which I prefer to use with some custom, formulas, but it's definitely possible to do that in a standard tool. You don't need a whole lot of code, to actually do that, but yeah, it's quite easy to implement if you're interested. Again,
Yeah, I think just taking 20 seconds from your time, Sagi, before you wrap things up. I think in response to some of the people that asked, how can we convince management and so on? Everything lies on mindset first. So if people understand that predictability is a range and it's not a fixed number, then we create a good discussion. And the other thing is that we need to update our prediction and estimations as we go along. This is the mindset that is needed in organizations. In many cases, this is not the case. People expect a fixed answer, and when you get a fixed answer, you get many mistakes and many buffers, and this is a problem. So I think we have 1 minute left, and we want to be predictable and finalized.
Right.
So Sagi, thanks a lot. Final words from you.
Just one thing before we wrap. First of all, I would love to get your feedback about, just a second, sorry, about the webinar. I'll post it. I posted the Menti again by mistake. So that's the link. That's a form. 2 questions there. Just a rating and some suggestions. Some feedback. Free form text. Please take 1 minute. It's all it's going to take you to actually provide the feedback. I'd love to get that feedback. We have some upcoming public courses. So if you're interested, like El said, we consistently get some great reviews about our courses. So you can see the list here. And there's a special discount for you guys who attended this webinar. You can use that code. It's valid till the end of August. So webinar June. And again, please fill the feedback form. And that's pretty much it.
Yeah, I think there is a problem with the link. It's showing a wrong question. I think it's showing the batch. I mean, what do we predict? So pressing on the link doesn't get me to the feedback.
Yeah, the second link there, the Google form.
The first one.
Let me check
the
it
second,
out. No,
the second might work.
Second one. Yeah, the second one. By mistake, I posted the
So please use the second one.
Yeah, the second one. The forms.gle. That's a Google form. Again, 2 questions. It's very much appreciated. So thank you very much, and see you in one of our upcoming courses or webinars, and have a great rest of the week. Bye-bye.
Thank you, Sagi.